This video demonstrates how to solve and graph quadratic inequalities. Solve the quadratic inequality algebraically. So this is a quadratic inequality in one variable. It only has x, and we're asked to solve for the possible values of x. So the steps that we want to take is first to change that greater than or equal than sign to just a plain old equal sign, and then solve the resulting quadratic equation for the two possible values for x. So we solve the quadratic equation by putting it in standard form, making it say equals 0. Always look to see if we can factor the left side of the equation, which here we can. What multiplies to make 28, that adds up to negative 11 is what I'm looking for. I choose negative 7 and negative 4. So I can see that my two solutions to the quadratic equation would be positive 7 and positive 4. Now because it was an inequality, we have to decide whether we're greater than 7, less than 7, greater than 4, or less than 4. And it's not always going to just be the same as the original sign from the equation, from the inequality. So in order to figure out the new correct signs for our final answer, I'm going to use a number line to visually display where these possible solutions show up. So if this was 0, 1, 2, 3, 4, 5, 6, 7, okay? And what I want to do, I don't really need to include 0 on here, but I like to. What I want to do is test the region in between the 4 and the 7 and see if anything in that region satisfies the original quadratic inequality. And if it does, then that's the region that I want to shade in. If not, I want to test to the left of the 4 and to the right of the 7 and see if that satisfies the inequality. So I'm going to test something in between the 4 and the 7 first, for example, 5. So I'm going to test the number 5 in the original inequality and see if it satisfies it. 5 squared minus 11 times 5. And I obtain negative 30 is greater than or equal to negative 28. Which is not the true statement, because negative 30 is less than negative 28. Therefore, 5 does not work, and nothing else in the region between 4 and 7 will work either. So I'm going to next test something that is to the left of the 4. For example, 0. Right? 0 is to the left of the 4. It's a nice, easy number to plug in. Replace this work with 0 to see that this side comes out to 0, it's greater than or equal to negative 28, which is in fact true. We want to include the 4 because the original sign had an equal than sign, or an equal to sign, and include everything in the region of the 0, which did work to satisfy the original inequality. And I would like to just test, for the sake of being thorough, something on the right side of the 8, or right side of the 7, such as 8. And see if that satisfies the inequality as well. Here we have 64 minus 88, negative 24. And that is greater than or equal to negative 28. And therefore the numbers including 7 and all of the values above 7 will also work. So when I then write my final answer, I'm going to go back to the answers to the quadratic equation and substitute in the new correct inequality signs. So x can be greater than or equal to 7. X can be less than or equal to 4. So this is just one way to solve the quadratic inequality, but it helps, the number line helps create like a visual representation of the possible solutions. So I like to use a number line when it asks you to solve it algebraically. Graph the quadratic inequality on a coordinate plane. So how do I know I'm going to graph it on a coordinate plane this time? Well, I have x and y in the inequality. So it's a function, it needs to go on the xy coordinate plane. The only difference between graphing this and graphing a quadratic equation is that there might be a dotted or dashed line instead of a solid line, and there might be shading on the graph. But we're going to start out by finding the vertex, which is always what we want to do to graph a quadratic equation or a parabola. The formula for the vertex when it's in standard form is negative b over 2a. So I'll plug in negative b, which here is 2, over 2a, and get 1. And I have to take the 1 and plug it back in to figure out what the corresponding y value would be. And so now I see that my vertex is located at 1, negative 4. That goes on the graph first, put it in red. And then I need more points to graph a quadratic, or to graph a parabola. So I'm going to plug in two things that are on the left of my vertex and two things that are on the right of my vertex. Create an XY table. So to the left of 1, the next two numbers we have are 0 and -1. And to the right of 1, we have 2 and 3. I'm going to plug those into the original inequality, or equation, and figure out the corresponding y values. Let's see, -1. This is going to be symmetric, and do the same thing on the other side. Plot the rest of these points. And now when I connect the dots to create the parabolic curve, because it's a greater than sign, it does not have an equal sign. It's going to be a dashed line. And then I need to determine whether I'm shading inside the parabola or outside the parabola. So I'm going to take this value 0, 0, which is not on the curve, and I'm going to plug it into the original equation, or inequality, and see if it satisfies it. So I have 0 is greater than -3. So because 0 is greater than -3, that's a true statement. That means I want to shade in the region that includes 0, 0, which is inside the parabola. And indeed, if your parabola continues on forever, which it does, it also includes all of this infinitely on forever. And that is all.